Okay. Okay, so stratified sampling. So before uh, we did this example on stratified, we saw that uh, we might encounter some issues while doing this randomness, right? If you remember, by randomness, we mean we want to pick up, let's say, if I'm a pollster, I'm doing a survey. Excuse me. I'm doing a survey for the next mayor election in Laramie, and um, I need to give, let's say, the current mayor the prediction uh, on how he will do in the next election. And if you remember, we started picking people from different places, of different ages, of different ethnicities, and all that. Um, Obviously, from the eligible registered voters, if you remember. Excuse me. And we know that we might encounter some problems while um, picking up those people randomly. And we say that it's unavoidable and it's quite expected when you do this random sampling. Okay. And in stratified sample, we first subdivide the entire uh, group of people, subdivide the population precisely uh, into smaller groups, into smaller clusters. Okay. And then we take samples from each of those groups. Then we say this is a stratified sampling. Okay. Oh, I think I have something in the chat. I can't hear you right. Is there anyone who is having the same problem? Can you hear me right? Uh, okay, so Grace, I guess it could be the network problem. I mean, the internet problem. So what you could do, you could probably log out and then join the meeting again. I'm not sure. This is the most naive approach I can say. Obviously, if your mic is working, if you're sure that your mic is all right, then I guess you can try logging in again. Okay, just let me know whether it works or not, because I can see everyone else is uh, all right. I mean, they can hear me. So I'm not sure what's happening with you. Please let me know, okay? All right. So now let's um, come back to our job as the pollster, okay? And let's say we can divide the population of Laramie. I mean, by population, here I don't really mean the residents of Laramie. Here, the population is actually the group where we are collecting data from, if you remember the definition. And we said the registered, excuse me, the registered voters is the population for our study. Okay, so let's say the population of Laramie, um, we can actually, uh, or rather, it's obvious that it's comprised of different uh, group of people in terms of supporting different political parties, right? So even if even if you haven't um, gone for a previous surveys here in Laramie, you can clearly understand then that there will be people who support Republicans. There will be other people who support Democrats, and there are some people who don't really care, right? Uh, who often change their mind and vote whomever they think that uh, um, good that they think they will be good for the city. So there are every possible um, things here, every possible choices. Okay, so let's say uh, if you have Democrats, Republicans, and um, let's say we can define it as independents. Okay, and if we know that uh, we need to pick up samples from each group, obviously, when you ask people, when you first approach them as a pollster, you will ask different questions to them. You will soon see what a real question is. The real question here would be to identify which political party that individual supports. But before that, as a pollster, uh, he or rather she will ask the name, where the individual lives, and all that different things, and then he will ask uh, which party he supports. And let's say uh, he has a certain um, uh, categories. For example, we say Democrats, Republicans, and Independents, and within within those categories, we already have previous idea. Let's say in the main election in Wyoming, it's all red. We already know that from previous election results. So, for example, in Laramie, let's say we have the previous data that there will be approximately 39% Democrats, just for example, 37% Republicans, and 24% independents. So if you pick up, let's say, if you just pick up 100 people for your survey, that's the sample, right? That's the smallish subset of the entire group of people. And you want that 100 people to be representative of the entire population, okay, which will give you a pretty fair prediction. So since you know from the previous elections that there will be approximately 39 uh, percent Democrats, so when you have a sample of 100 people, uh, you will just uh, try to stop when you already have 39 Democrats, approximately 39 Democrats, okay? And that's because you want to take uh, predictions from different people as well, from the other two categories as well. So that one possibility could be when you are picking up data from 100 people, one possibility could be there will be 70 out of those 100 who could support Democrats. And if you just um, take those results and predict the election, that might not be enough. Can you see what I'm saying? Because we know from the previous election that there could be approximately 39% Democrats. It's not precise because it could change, but to uh, make your data more and more precise, what you could do, you could, when you have already reached about 39 to 40 people who support Democrats, you can stop taking their opinions. You can look for people who support Republicans. So, for example, in this problem, it says in a sample of 1,000 people, they would then expect to get about 39 Democrats, because, as I said, it was 39%. So, in a 1,000 people sample, you expect about 390 people who support Democrats, and similarly 370 Republicans and 240 independents. Okay, but again, it's not precise. You can do different things with this, but you need to make sure that when you are getting data, when you're collecting data, uh, it doesn't become so one-sided. As a pollster, you need to decide where to stop and when to stop, right? So this is just one uh, way to sample your data, and we say that it's a stratified sampling because we have subdivided the population into different stratus. That means different subgroups, and then we want to pick up collection. We want to start picking up people from all those subgroups, all the smallish groups of the entire population. Okay. Let's see one more definition, and then we'll try to use one more example with our class, Math 1000. Okay. All right. One more sampling could be quota sampling. Now, what is a quota? What do you understand when you first uh, see the word quota? Anyone? Don't go for the definition first. What do you understand by the English word quota? Anyone?
You meet your quota at the end of the year, maybe. You have a goal of how much money you can make, and if you hit your quota, you don't hit your quota.
Okay. Anyone else? Oh, I think I have something in the chat. A limit or a specific number that you need / want to attain. Okay, that's good. So when you have a certain, yeah, I think that's a good definition. When you have a certain target to achieve, okay? So for example, uh, when I was in Reno, Reno, Nevada, a couple of months back for my master's, uh, I was once chatting with a police officer, and he said each month he has a certain number of uh, cases which he needs to file, for different cases, for driving errors, for crimes and all that. But as a police officer, he has a certain target, certain number of cases he needs to achieve. So you might say that it's a quota he needs to satisfy. Okay, so that's yeah, I think that's a specific number you want to attain, you want to have, right? So yeah, that's a good definition of quota. Anyway, so what could it mean when you say sampling, when you say excuse me, when you say quota sampling, what could it mean? That could be a very good uh, very good question to ask yourself, right? So let's see. The next example, and I hope uh, if you understand the next example, you don't even need to see the definition. You will just understand by the way it has been done. Okay, so let's say example 9, and then we'll come back to the definition. Okay, so example 9 says, suppose the pollsters call people at random, but once they have met their quota of 390 Democrats, they only gather people who do not identify themselves as a Democrat. Just as I said in the last example, right? So he expects, or as a pollster, you expect that there will be approximately 39% Democrats. So when you have a sample, let's say of 1,000 people, uh, you can stop collecting data from Democrats when you have already collected data from 390 of them, because you know that it should be approximately 390 out of those 1,000. So you have already attained the number you assumed for the number of Democrats in your sample. And it could be even the first 390. That's a possibility, although it's less likely, but that's a possibility. So when you already, if you are tracking that, of course, when you have already seen or collected data from 390 Democrats, you can stop because you have already uh, made the target for the Democrats. You can still carry on doing that, but if you stop doing them, then we say that it's a quota sampling, because the pollster uh, have already, or rather has already met his or her quota of 390 Democrats. Or it could be the other way as well. He could um, stop picking up Republicans when he has um, 370 Republicans in total, approximately. Okay, so we say that it's a quota. Now, let's go back to the definition, and then we'll stop for a while to see whether it makes sense or not. Okay, so the definition says quota sampling is a variation on stratified sampling, wherein samples are collected in each subgroup until the desired quota is met. Okay, can you see the definition? Even if I didn't see the definition, I could see from the example that I need to I need to achieve a certain number, and then I can stop um, stop collecting data for that particular subgroup. And if I keep doing that, I can say that I have satisfied all the quotas. I might have more than one. I definitely would have more than one if I, since I'm collecting data from different stratas and different subgroups, I'll definitely have certain quotas to satisfy. And that way, I could define it as a quota sampling. Now let's take a break. And if you have any question, you can ask now. These are really precise and really precise definitions. And again, in your homeworks and your exams, you will be asked to identify which type of sampling you are dealing with. That will be really crucial, okay? And that's why I'm repeating myself. Try to understand the definitions completely. Right? Okay, I have one question. Let's go for that. What's a situation in real life where quota sampling would be used? Okay. All right. Yeah, we can look for one real life situation where quota sampling could be used. Uh, okay. So I could share my experience, although it uh, doesn't really uh, mean a good example for the quota sampling, but it's a good example of quotas being met. Okay, uh, for my PhD candidacy, I need to achieve certain things before I get my diploma. Okay, for example, the first one is I need to pass a foundation exam, then I need to pass a qualifying exam, then I need to pass a preliminary exam, and then obviously I need to defend my dissertation. So I probably need four things, and the fifth thing could be I need to pass different courseworks. Okay, I need to go over different coursework and do well in that, at least a B or more in each of those courses. So let's say I have five categories. Okay, so these, you might say these are the five subgroups of the entire population. The population could be the people who are trying to get their PhD. Okay, and you have five different subgroups. That means the people who needs to pass the foundation, qualifying, fully defend their dissertation, and uh, get a B or more in each of the required courses. Okay. Now, what could be the quota sampling? I mean, as I said, I'm making up this example, so it may not be a very good example, but I guess it will make more sense. Okay, so previous data uh, suggests that one student might pass the foundation exam if he gets, I guess, 40%. If he gets just about 40% in the exam, 40% uh, in that exam. Okay, so out of 100, previous studies suggests if a student get 40 or more, he will pass the exam. That's the previous data, by the way. It could change. For example, if the examiner thinks, or uh, whoever checks your answer script, if he thinks that no, I want more, I want 50 or I want even 60, that could change. But previous data suggests that if you get 40, you will pass the qualifying exam. Okay, so that's a quota for the qualifying exam itself. If you have more, I mean, it's an exam, so you could get more than 40. That's not a problem. But if you have got 40, your quota is met, you can proceed to the next one. Okay, you don't need to appear for that exam again. You can stop there. And obviously, you have only two chances to pass it. In the qualifying exam, they expect you to get, I guess, 80 out of 100 to pass it, something like that. The previous data suggests. So you need to achieve this number, this particular target before you move to the next one. So your quota of this particular subgroup will be to get an 80%. And you can keep doing that for different categories as well. Okay, as I said, it's not a very good example because I'm making this example. So, and this is not uh, a statistical uh, example as well, because you'll have uh, certain parameters in all these five subgroups as well. It's a more sophisticated one. But yeah, you could think this as an example because you could see there are certain numbers to achieve. Okay. Oh, someone has entered the meeting. Oh, it's already 9:08. Anyway, all right. Okay. Any other questions? When you will appear for the exam or for the homework, you will definitely see a story is written there. There will be different data. There will be different um, things you need to consider. And when you see the entire story, you will see you have um, different things to match. I mean, you know the definitions, you can always memorize that, different sampling types and all that, quota sampling or precisely stratified sampling. Then you'll have cluster sampling up next, different sampling methods. And from that story, obviously, as I said, a story will be given. From that story, you need to match those things with the definition you know. Okay. And say that by eyeballing this uh, data set or the way uh, they have done this sampling, I can say this is this type of sampling. The method is this. You need to differentiate those. Okay. It will be really tricky because it will be designed in a way so that it confuses you. Okay. Yeah, that's the truth. You need to uh, understand the entire story first. We'll do examples before we do such homework or exam problems. Okay, no worries. Okay, let's see. Okay, cluster sampling. All right, but before that, if you remember, I did say that often um, you will as a pollster, you will not ask real questions to the uh, people on whom you're doing the survey. And what does this real question mean? Okay, so in the quota sampling, obviously you have certain number of people uh, uh, at the back of your head ahead uh, to complete your quota. So when you have already met your quota, then you already know that, hey, I don't really need any more people from this particular subgroup. Okay, now what can you do? Obviously, you can't really say by face reading that which political party this guy might support. So what you could do, you could ask different questions. You could start with that. For example, as a pollster, uh, let's say if you are collecting data over phone, you can start asking by that individual's name, income, and different questions, and then you could you could ask uh, whether or not he support Democrats. If he does, then what you could do, you could thank him and hang up before going for the detailed survey you actually need. So that could be the real question which you didn't ask because you have already met your quota. And that's obvious when you do a phone call. For example, I'm dealing with Frontier Airlines for the last couple of days for certain issue. And when I call them, they actually start by greeting and asking how my day is going on and different things. Okay. And then they ask the real questions. That means the questions they need for a particular survey or whatever the reason is. Okay. All right. Okay. Now, is quota sampling easier than stratified sampling? Okay. So often, yeah, if you have previous data, if you know what's your approximation from the previous surveys and all that, then it's definitely easier than stratified sampling because you know the number, the approximate number already, and you just need to meet your uh, target. You just need to meet your quota. So you can have several uh, categories. Once you have met that, you can go for the other categories and ignore the category or where you have already met your quota. Okay. But again, as we said, uh, the last time we met and today when we started that, um, you might encounter some pretty obvious and unavoidable issues when doing this randomness. Okay. But and it does not ensure the same level of randomness when you are doing the quota sampling either. It can't, because it's from the previous assumptions. So it could be wayward, it could have changed in the last couple of months. Let's say you had the survey 5 months back, or it could have been 2 years back. So within these 2 years, uh, these assumptions uh, could have actually turned the tables. It could completely change. But yeah, uh, it often is a good strategy when you have enough data. Okay. All right. Next we have cluster sampling. Okay. Now, what does uh, the cluster sampling mean? Again, we'll go for the example first, and then we'll come back to the definition. Hopefully, it will make more sense. Okay. Okay. Example 10. Let's say the college wanted to survey students. Okay. Since students are already divided into classes, they could randomly select 10 classes and give the survey to all the students in those classes. This could be a cluster sampling. Okay. Now, a college have several classes, right? Several classes. Can you name some of those, since you have been to college already? Can you name some of the classes uh, a college might have? Anyone? Can you name some of those? Just give it a try. Okay, English 1010. All right, next. I guess you can clearly name some of these classes pretty easily. You can just name the ones you have already completed. That's yeah, this class, yeah, very good. Anything else you have already done in college? Maybe. Obviously, it's not the only one you are doing this semester, right? Most of you are doing at least 3 or 4 of these courses. Western civilization, Spanish, okay. Hmm. Anything else you're doing other than this course? First year seminar, okay, yeah. Let's say, for example, I could mine as well, international relations, okay. I could add mine as well. I have um, abstract algebra. I have numerical analysis, and I have uh, a course on mathematical modeling. What's Kojo 1000? What's that? COJO 1000.
Communications.
Ah, okay. Okay, criminal law. Yeah, very good. So you can see we have several classes, right, in a college, starting from first year courses to graduate level courses, you know. So we probably have, more than 100 classes in a college. I guess it should be more. It should be more, right? Yeah. So what you could do, you already have those subgroups here. If you consider different classes, you already have these subgroups. Now what you could do, you could randomly select a couple of classes out of this. Okay, so you already have the subgroups. Now you are just randomly picking up subgroups from the groups you have. Okay, and what you want to do is, now you want to conduct your survey on all the students in these courses. So you have already shortened your list. Let's say, for example, we had 1, 2, 3, 4, 5, 6, 7, 8, and adding my 3 as well. We already said 11 names. So we already have these 11 subgroups. Okay. And excuse me. So now what I'll do, if I'm doing a survey, I'll just randomly pick, let's for example, say 3 classes out of this 11 we have just named a couple of minutes back, and we'll try to pick or rather collect data from all the students in these 3 randomly picked classes. Okay, so then we can say this sampling method is a cluster sampling. Experiencing technical problems. Oh, okay, no problem. As long as you can rejoin and you can see the discussion, or rather hear the discussion, that should be fine. No problems. Okay. All right. So we say that it's a cluster sampling. Now let's just go back to the definition and let's see whether it makes sense or not, right? Okay. So the definition says, in cluster sampling, the population is divided into clusters or subgroups, and a set of subgroups are, you can see, a set of subgroups. So you already have the subgroups, and then you are just picking up a couple of from those subgroups to be in the sample. Okay. Now, does it make sense? Just try to match the example with your definition. Try to see whether it matches or not. Okay. Any questions so far? Anyone? All good? Okay. And let's have one more definition and then we can wrap it up today. Okay, the next one we have is the systematic sampling. Okay, once again, we'll do the same thing. We'll see the example first. Excuse me. And then we'll see the definition, whether or not it makes sense. Okay. All right. Example 11. It says, to select a sample using systematic sampling, a pollster calls every 100th name in the phone. Okay, so as you can see, he is actually picking up people with a certain number working on that. So by calling the 100th name, every 100th name in the phone book, he means, let's say you have a phone directory where you have uh, all the phone numbers in Laramie, all the phone numbers, and uh, the name and the address associated with that phone number. You have the detailed information there. Okay. Couple of years back, let's say, I guess 20 years back, I remember we had one in our apartment, back in my country, where um, we had all the phone numbers, the names, uh, whom the phone number belongs to, and I guess the address as well, etc. So and obviously in Laramie, we have at least 1,000 phone numbers, right? Maybe less than that because we have a really smallish population here in Laramie. Anyway, let's just say we have 1,000 phone numbers, landlines, obviously, I'm talking about. So, what he's doing, the pollster, he's calling every 100th uh, name in that phone book. That means the 100th guy, the 200th guy, 300th guy, 400th guy, and he keeps doing that for each 100th name. So what he's doing here, although he is doing this randomly, okay, because he doesn't know whom it could be on that particular 100th name, so there is certain randomness there, but he is maintaining a systematic way here as well. Can you see that? Because he's only picking up every 100th people, right? Can you see that? Now let's see the definition. It says in systematic sampling, every nth member of the population is selected to be in the sample, every nth. So that means here you are defining a system, although there is still randomness, no doubts on that, because you don't know whom it could be or what it could be for different populations. And just what you're doing, you're just defining the randomness. Okay. And then you keep doing that. For example, I guess we have, how many of you guys are present today? 14. Okay. So let's say I want to pick someone for volunteering in COVID vaccines next week. Okay. And I have to do this from this course. So what I could do to have randomness, I actually often do that. I guess you could see when I ask questions, I actually go to the participants list and randomly pick people. I don't really have anything precise though. I just randomly pick someone's name and ask him that, what do you think it could be? If you remember, I have been doing this, right? So that's a random sampling as well. You could see, you could definitely say that's a random sampling. Okay. I didn't really uh, do anything specific like stratified or quota because I've just randomly picked up people. But if I do, let's say, if I start asking questions every second name, so one name after another, okay, I just pick one name, skip the next one, and then ask questions the next one, then skip the next one, and then ask question to the next one, next in the participants list. If I do that, then I'll say that, hey, I'm picking up every second member from the participants list. Then it's a systematic sampling. Can you see that? Right? Does it make sense? Okay, now let's see what are the drawbacks we might encounter. Okay, so systematic sampling is not as random as a simple random sample. Okay, why is that? Okay, so let's say the example we had of calling every 100th name in the phone book could be problematic. Why? Uh, let's say your name and your brother's name or a sister's name, obviously, in most cases, has the same last name, right? And if we just follow the phone book, then uh, it's less likely. I guess there is no way uh, uh, both of you could be picked for the phone call, right? Because if you are picking up the every 100th people, it's less likely that two people with the same last names uh, would have 100 people in between them. It's less likely. Even if you pick every 10th people, still it's less likely that both of you and your brother or your sister will be picked for the phone call. So it's not really simple random sample because not everyone has the same chance of being picked. But yeah, it's, as I said, there is still randomness because you don't know whom it could be on the 100th name, right? So it can yield acceptable samples, as you can see. All right, so let's stop here, and we'll keep meeting on Wednesday, I guess. Yeah. And before we meet, I want you guys to go over the next couple of definitions and examples. So what you could do, yeah, I guess your pre-class assignment will be try it now 4 on page 236. That will be a very good example, let me say. That will be a very, very good example. Your exam or homework questions could be pretty similar, let me tell you, okay? So pre-class assignment would be 230, try it now 4 on page 236. And obviously, uh, you can just go over the example 12 and 13. You don't need to turn that in. You just go over those examples and try to understand what they're trying to convey. Okay. All right. So let's meet on Wednesday.